define a piecewise function. A piecewise function is a function defined by different equations over different parts of the domain. For example, here we have our function f of x, and we're going to define f of x as negative 2x minus 4 if x is less than negative 1, and we're going to define f of x as x plus 1 if x is greater than or equal to a negative 1. So here we have our function defined by different equations depending upon the domain of that particular x. So here we have our first domain. We have a domain when x is less than negative 1. And we have our second domain that if x is greater than or equal to negative 1. Depending upon our x value, our function will act appropriately. So let's use this information to find f of negative 5, f of 0, and f of 4. First, for f of negative 5, here we have an x value of negative 5, so this will be for our domain that is x less than a negative 1. This function is defined as a negative 2x minus 4, so our function then becomes negative 2 times negative 5 minus 4, which can simplify to 10 minus 4, which is equal to 6. So f of negative 5 is equal to 6. Well, next, let's determine the value of f of 0. Here we have an x value that's equal to 0. We can look for the specific domain. Here we have our second domain when x is greater than or equal to negative 1. Our function is defined as x plus 1, so this function then becomes 0 plus 1. 0 plus 1 is equal to 1, so f of 0 is equal to 1. Next, let's determine the value of f of 4. Here we have an x value that's equal to 4. The specific domain where x is equal to 4 is when x is greater than or equal to negative 1. 4 is greater than or equal to negative 1, so our function will be x plus 1. This simplifies to give us a 4 plus 1, which is equal to 5. So since our function is defined as different equations over different domains, we first have to determine the domain of where we're going to analyze our function and then apply the appropriate equation. Well, we can also graph piecewise functions. So if we wanted to graph f of x as our piecewise function, let's look at how we would do this. Our first step will be to divide our domains in half. We have our first domain where x is less than negative 1, and we have our second domain where x is greater than or equal to a negative 1. So we drew a vertical line in order to separate those two domains. We'll then want to graph our two equations. We can graph y is equal to a negative 2x minus 4. Let's put this in a dotted line. And we also want to graph our second equation that y is equal to an x plus 1. Here, notice we have our two graphs. We'll then want to fill in where these graphs are applied over our different domains. When x is less than negative 1, the appropriate equation is y is equal to a negative 2x minus 4. So we can draw this in with a solid line. Notice we have an open circle because we have our less than. Over the domain of x is greater than or equal to negative 1, the correct equation is y is equal to x plus 1. So we'll draw in a solid dot, and we can then shade along our y is equal to x plus 1 line. We can then erase our dotted lines, and this will represent the graph of our function f of x over the different domains. Well, let's look at another example. Here we have a piecewise function. F of x is equal to a negative x plus 1 if x is less than negative 3. Our function is defined as 2x if negative 3 is less than or equal to x is less than or equal to 1. And our function is defined as a negative x squared plus 1 if x is greater than 1. With this piecewise function, we have three domains. We have our domain that x is less than negative 3. We have a domain that negative 3 is less than or equal to x is less than or equal to 1. And we have our third domain that x is greater than 1. With this function, let's find f of negative 8, f of negative 2, and f of 5. First, for f of negative 8, here we have an x value of negative 8. We'll want to determine the domain where x is negative 8. This is in our top domain where our function is defined as negative x plus 1. So f of negative 8 becomes a negative 8 plus 1, We can simplify this to get an 8 plus 1, which is equal to 9. So f of negative 8 is equal to 9. Next, let's define f of negative 2. Here our x value is equal to negative 2. Let's find the appropriate domain where x is equal to negative 2. This will be in our middle domain where our function is defined as 2x. So f of negative 2 becomes 2 times a negative 2, which is equal to negative 4. So f of negative 2 is equal to negative 4. And finally, we want to find f of 5. We want to find the domain where x is equal to 5. X is equal to 5 is in our bottom domain when x is greater than 1. Our function is defined as a negative x squared plus 1. So f of 5 becomes negative 5 squared plus 1. We'll apply the squared before the negative, which becomes a negative 25 plus 1, which is equal to a negative 24. So remember, depending upon where our x's fall in the different domains, this will give us the different equation in order to find f of x. Well, let's graph this following function. We have our function over 3 domains. Our first step will be to draw our vertical lines that will separate our 3 domains. We'll have a vertical line at x is equal to negative 3 and x is equal to 1. We have our 3 domains. We have our domain that x is less than negative 3, our domain between negative 3 and a positive 1, and our third domain when x is greater than 1. These will be our 3 domains of where our function acts differently. Our next step will be to draw in each of our equations with a dotted line. We'll graph y is equal to a negative x plus 1. We can then graph y is equal to 2x. And lastly, we can graph our third equation, that y is equal to a negative x squared plus 1. We'll then want to apply the specific equation over the correct domain. For our domain that x is less than negative 3, the appropriate equation is y is equal to a negative x plus 1. So we'll draw in with a solid line our y is equal to negative x plus 1. Notice we're going to leave an open circle over the value that x is equal to negative 3. In the middle domain, or our green domain between negative 3 and 1, the appropriate equation is y is equal to 2x. Here we have our less than or equal to, so we're going to have solid dots, and we're going to draw in with a solid line y is equal to 2x. And then on our third domain, where x is greater than 1, we have the appropriate equation that y is equal to a negative x squared plus 1. So we'll have an open circle, and we can shade in with a solid line y is equal to negative x squared plus 1. We can then erase all of our dotted lines. And once we've erased all of our dotted lines, we can see here that this will be the graph of f of x over our 3 domains.